Hello, welcome to the third video of Science Extension. We're looking at falsifiability and confirmation bias. So first, falsifiability. A hypothesis is falsifiable if there's an observation that can contradict it. So the very first and obvious example of this is the statement, all swans are white. Okay, for a long time we thought all swans were white because all swans found in most of the world are white. Until we eventually came to Australia, to Western Australia, and we found a black swan. But the statement, all swans are white, you can have an observation that can contradict it. If I observe a black swan, or even if I say I've observed a black swan, that's contradicted the hypothesis. We could say all swans are white. Falsifiable. A non-falsifiable statement could be that there is a black swan. So say before Australia is discovered, these two statements could have been made. Okay, all swans are white. Yes, it's falsifiable because if I make an observation of a swan that isn't white, I can say this statement is not true. I've made an observation that contradicts it. However, there is a black swan. What kind of observation can you make that contradicts that? I can say, I can show you a white swan. I can say, here's a white swan. Does that contradict this statement? No, there could still be a black swan, even though I've shown you this white swan. If I show you 50 white swans, there could still be a black swan. If I show you a photograph of the entire surface of the Earth and point at every animal that we can see there and show that there is no black swan, there could still be a black swan. It could be on a different planet, or it could be underground, or it could be in someone's house. You never know. So there's no observation you can make to say that this statement, there is a black swan, is false. Therefore, it is not falsifiable. The importance of this scientific research. So it is very important that our hypotheses are falsifiable because that allows us to challenge our own beliefs, right? If we believe that all swans are white, then this first statement is a good one to make because then someone can challenge our belief and we can be shown to be wrong. If we believe all swans are white, let's just change this statement up a little bit. We could say, I'm trying to think of one, let's say most swans are white. This is another statement that is not falsifiable. Even if I show you 100 black swans and I show you only 50 white swans, you could say, well, there's possibly another 100 white swans out there as well. It's another statement that's not falsifiable. And so if nobody can ever prove you wrong, then you're not going to change your opinion if you are wrong, right? Your opinions can be right or wrong, but this statement can't be proven right or wrong. And without proof, there is no science, there's no progress. Statements that aren't falsifiable, these often lead to pseudoscience. It sounds scientific, but because it can't be proven incorrect, there's no way for it to adapt to new data, and so it's pseudoscience. So one example of that is astrology. So I've pulled up my horoscope for the day. Let's see how falsifiable the statements it makes are. So here we go. Today, the level of risk is much higher than I initially expected it to be. Okay, so this is not falsifiable in multiple levels. For example, what I expected it to be can't really prove what I expected the risk to be. You also can't prove what the current level of risk is either. If you go out and you measure and you make some observations of what the current levels of risks are, you can either say that you haven't measured it enough. So say you measure the risk and you look at, I don't know, the amount of traffic on the road to see if I'm going to get into a car accident. You say the risk here is 0.1% of getting into a car accident. Someone could easily say there's risks of other things that you have not thought of. You know, and what I expected it to be, well, yes, that is the risk, but you expected it to be lower. And I can say, no, I thought it was higher, but there's no way to prove this statement wrong. Okay, this statement could be true. Today, the level of risk might be much higher than I expected it to be. I have no way to prove that wrong. And that's where the power of this pseudoscience lies, and why so many people believe it, and why it's so hard to say that astrology is wrong. Okay, wherever there is high risk, there is potentially high reward. Well, there's potentially high reward anywhere. But again, a statement that this statement is true. Whenever there is high risk, there is potentially high reward. That is a true statement, and it's true because of this potentially. Because potentially means it could be there or it could not. This statement is actually, it's true because it doesn't say anything. There's a potential for you to be embarrassed, and there's a possibility that you'll earn great acclaim. So potential and possibility, again, they are not statements that are saying anything. If I get embarrassed, sure, yeah, of course, they said there's a potential for you to be embarrassed. If I don't get embarrassed, they said, well, it was only a potential. So no matter what observation you make, it's still not proving this sentence wrong. There's nothing in here, there's nothing in this horoscope that can be proven wrong at any point. At which point it makes you wonder why you should believe it. A statement that can never be proven wrong is not a useful statement. Okay, let's go on to confirmation bias. Quite a similar thing, and again, horoscopes can come into it. And it is something else that we need to avoid in science. So confirmation bias is the tendency to interpret results in a way that confirms your existing beliefs. Okay, so if you believe in astrology, and say if something doesn't go my way today, you would say, that's because the level of risk was much higher than you expected it to be. But say if something does go my way, you could say, that's because of the high rewards that came with the higher risks, right? You got great acclaim because of this positive thing that happened in your life. So today, no matter what I do, if something bad or good happens, someone who already believes in astrology can use this horoscope to confirm their own bias, right? They can interpret that result to confirm the belief they already had. So we've already looked at scientific thinking, and we've searched for evidence for a theory, that's inductive reasoning, and then we try to falsify the evidence, that's deductive reasoning. So in this inductive research, where we're trying to confirm evidence, we're trying to put together observations and create theories based on those observations, this can have a serious problem with confirmation bias. And throughout this history of science, there have been lots of examples where new theories have come along that turned out to be probably correct. New theories have come along that have disagreed with most people's traditional beliefs, and there's been a lot of resistance in the scientific world to these new theories because of confirmation bias. Plate tectonics, which we've already talked about, people interpreted the results to solidify their existing beliefs. The fact that there's no ether, already talked about that. Theory of evolution by natural selection. People interpreted the results and observations to favor the theories they already had. This is also seen in a lot of science experiments done in high school. Anytime I have students who are designing experiments, and especially when they're writing their hypotheses, they're really worried about it because they say, what if my hypothesis is wrong? Do I fail? No, the fact that your hypothesis could be correct or incorrect is an important part of science. Your hypothesis should be falsifiable, so it should be possible for it to be incorrect, but also you should be open to the idea that it could be incorrect because you should try to eliminate your own confirmation bias. You think it's going to be correct, but um, by doing the experiment, you can create observations that can show that your hypothesis is incorrect or it's less likely to be correct. Um, so yeah, having an incorrect hypothesis could be a good thing. This is also why people do blind studies, or even better, a double-blind study. That's where I design the experiment, and perhaps I have um, two cases. Perhaps I've got two plants, and they look identical, but one of them has been injected with some kind of toxin. I want to see which one grows better. Um, Instead of me looking after and measuring the height of the plants, I would get someone else to do it. They don't know which plant is which. I know, but they don't, and they do the measurements. Um, if I was doing the measurements, when I'm measuring the poisoned plant, I am going to think, I'm going to be expecting it to grow less. So I might subconsciously adjust the way that I'm measuring based on that belief. But someone who doesn't know which one's which, they're just going to measure the plants. That's the job that they're meant to do, and they're not going to have that bias. So without having the bias, there can't be any confirmation bias. And then the results they give me, I just have to accept the numbers. Um, there are still ways to interpret numbers to um, confirm with the bias you have. Maybe they say the plant that was poisoned grew much taller, and I might say, well, it's growing more because it's cancerous or something. Who knows? I can still have confirmation bias, but at least making it blind, um, can help a little bit. Double blind is when I don't even give the plants to the person. Um, I create the study, I know which plant is which, but then someone else organizes the plants, gives them to a third person to really prevent any of this bias. Maybe when I give the plant to the person, I say, here's a plant and here's a plant, look after this one. Like, maybe I'm going to give them hidden clues as to which plant is the one that I expect to grow better. Okay, two serious issues to look for in science, especially anything that you think might be pseudoscience. If you look at a lot of science that goes around on social media, have a look for these two things. Are the statements falsifiable? And is there confirmation bias? Is the evidence really pointing towards what the person is saying? Or are they just interpreting it that way to confirm their existing belief?